Hello everyone and welcome to the seventh topic in the SS1 physics curriculum. Now this is still a part of motion and what we are looking at is in this topic is circular motion, putting special focus into circular motion and the entire concept of it. Now to those of you who are new to this channel, here on this channel we ensure that we simplify your classroom topics in a way that you get to understand it and be able to solve multiple problems with it without any issues at all. And we've been doing this for a while, so please ensure you check out our videos that are on the channel and ensure that you give us a like. Also ensure that you subscribe to the channel. Now, like I mentioned, in this topic we are looking at circular motion, and what we'll be looking at in more detail here is first understanding the simple idea behind circular motion. That is, what is circular motion? Mention some objects that perform this motion, and then we'll look at some facts that we can establish from objects that perform circular motion. Then secondly, we'll look at what is known as the centripetal acceleration and centripetal force. After that, we then look at the centrifugal force, and then we look at angular speed and velocity. We solve problems involving angular speed and also solve problems involving angular velocity. And then after that, we now look at multiple problems from the WAEC exams, from UTME exams and other professional exams on the circular motion. So we'll be able to solve multiple problems. And please, if at any point you have any question, perhaps on what we are doing or any of the subjects that we've covered, please ensure that you drop them in the comment section, and we'll definitely attend to every one of your comments. And please don't forget to like, share, and subscribe to the channel. So if you're ready now, get your materials and let's explore the world of circular motion. Let us look at what circular motion is. Take, for example, if you tie a string around a stone and whirl it, that stone is going to move around a circular path. That kind of motion is circular motion. The same can be said of Earth and other planets revolving around the sun. They also undergo circular motion, as well as the moon. As it goes around the earth, it goes about a circular path, so that is also circular motion. So if we are going to define circular motion, we will say circular motion is a motion where an object goes round about a circular path. Okay, whenever an object goes along a circular path, that object is observing circular motion. So let's put that down. Circular motion is the movement of an object along a circular path. Now, some things that we can observe in circular motion is that in circular motion, the speed is constant. An object observing circular motion does so at constant speed. Now, even though this speed is constant, the velocity is not. Now, the reason behind this is this. Let's take, for example, this being a circular path with a center here and a radius r. As the object goes around this circular path, now what do we see? In a circle is an end gun such that n is close to infinity. That tells you that the direction will change. Direction changes constantly. Okay, there's always change in direction. Therefore, what that means is that you are having a displacement. So, therefore, the velocity will change with direction. So, as a result, it does not have uniform velocity. It has a constantly changing velocity, which gives rise to what we know as acceleration. Okay, so back again. remember that circular motion is the movement of an object along the circular path, right? And we know that the speed is constant, and even though the speed is constant, the direction is changing rapidly, so velocity also changes. So now let us look at the acceleration of objects along a circular path. Now that we have established that in circular motion, the object is moving round a circular path. Now, we also know that the speed is constant. However, it is constantly changing direction. And because of this, it gives rise to a changing velocity. And whenever you have a changing velocity with respect to time, you have acceleration. Now, how do you get the acceleration of an object performing circular motion? Now, this acceleration is often called centripetal acceleration. Now, note that centripetal acceleration denoted A subscript C is given as the square of the velocity v squared over the radius, right? So when you have the circular path through which this object is going, you need the radius r, and then you need the velocity v. So you can apply this equation, A equals v squared over r, for centripetal acceleration. Now, in case of centripetal force, now let's define centripetal force. Centripetal force is the net force acting on an object in circular motion, which keeps the object on its circular path. So that is, when you tie a string to a stone and then begin to whirl it, the net force that keeps that stone along the circular path is known as the centripetal force. Now, normally you know that force is supposed to be mass and acceleration, right? So if we apply that here, centripetal force Fc, F subscript c, would then be the mass of the object multiplied by centripetal acceleration. Now, therefore, centripetal force is therefore mass multiplied by centripetal acceleration, which is v squared over r. Now, these are the equations that we use whenever we are solving anything that has to do with centripetal force or centripetal acceleration. Let us now apply this to solving a few questions. Let us apply the equation for centripetal acceleration to solve this problem. This says a car is moving at a constant speed of 20 meters per second around the circular track with a radius of 50 meters. Now we are to calculate its centripetal acceleration. Now to solve this, let's see what we have. So we are given that v is 20 meters per second. We're given the radius as 50 meters, and we are asked to find centripetal acceleration. So centripetal acceleration is v squared over r, so which implies we're going to be having 20 meters per second squared over radius, which is 50 meters. So now centripetal acceleration is 20 squared will give you 400, and this is meters squared per second squared, all divided by 50 meters. So meters here, so we are left with meter per second squared, and this here goes 1. So what we see here is 40 divided by 5, which is 8. So we see 8 meter per second squared as the centripetal acceleration. And that's the solution to this question. In this question, we are told that a ball of mass 0.5 kilogram is tied to a string and whirled in a circle of radius 1.2 meters. Now, this was done at a speed of 6 meters per second, and then we are asked to calculate the centripetal force acting on the ball. Now, you already know the equation for centripetal force. Now, you can pause the video apply that equation to solve this question and see if your answer is the same what is gotten at the end of the video. Now let's solve. So the equation for centripetal force is mv squared over r. So if we are applying this, the mass is 0.5, that is 1 over 2, multiplied by v. V is 6 squared over r, which is 1.2. Now let's tidy that up. Centripetal force therefore becomes 36 divided by 2 times 1.2. So now we have 36 divided by, this is 2.4. So you can write this and say 360 divided by 24. Now when you divide this, you should get 15. So, and force is measured in newtons, so the centripetal force is 15 newtons. And that's the solution to this question. Leave us a comment if you got the same answer as this. We have established what centripetal force is, and one more thing you need to understand about that is that the centripetal force on an object surrounding a circular path always acts inwards. Now, there is another force that tends to act in the opposite direction of this. Like for example, when you are whirling a stone around a circular path, you feel as though the stone is trying to move away from that circular path. You feel it while you do that, even though you cannot quantify it exactly. And the same thing happens when you're driving around a curve. The moment you turn, you feel a force pushing you away from the direction the car is moving. It slams you towards the door. So you always have to brace yourself. There's that force that is acting to push you away from the center of that circular path that you are rounding. Now, this particular force is called the centrifugal force. Now, it is often called the pseudo force. It is a pseudo force in the sense that it is just something that is felt, not directly quantified. So if we're going to define it, we'll say it is the force that acts, the apparent force that acts to pull an object away from the center of the circular path it is rounding. So let's put this down. Centrifugal force is the apparent force which acts to pull objects in circular motion away from the center of its circular path. So that pseudo force felt there is known as centrifugal force. Now it cannot be correctly quantified, but according to the Newton's third law of motion, we believe it to be equal to the centripetal force. So oftentimes we say centripetal force and centrifugal force are equal. So centrifugal force equals centripetal force, which is also mv squared over r. Now, this is how we define centripetal force. Now, even though you may not be asked to calculate it, you should also know that it is equal to the centripetal force by using the Newton's third law of motion that says actions have equal and opposite reaction. So this is how we get centrifugal force. If you have any question, please drop it in the comment section and we'll definitely attend to all of your questions. Let us now look at angular speed and velocity as well as their relationship. Now, to understand angular speed is the rate at which an object is able to cover a set angle. So an angular speed is denoted W. So remember, angular speed is the rate at which an object covers an angle. Okay, so and it is denoted W. Okay, so we then say that is now the angle theta over time. So whenever you're asked to solve question involving angular speed, you can use this equation. Angular speed equals theta over t. Now, to relate this with velocity. Now, velocity is displacement s over time. But displacement s is the angle multiplied by the radius, right? So if we work with this, we can now get what angular velocity is. So angular velocity can then be written as theta r over t. Now, back to what we have here. Now, we can then use this to derive for what v can be. Now, w itself is theta over t, right? Theta over t. So if we break this down, v is therefore, we have this theta over t times r. So this will then be wr. So v is wr. So this is the relationship between velocity v and angular speed w. So when you find question where an object is rounding a circular path, you can find the velocity of that object by using this equation, and you can find the angular velocity by using this equation. Now let's solve some examples of this.
Camera rolling. 3, 2, 1, go.
This question says, a stone rod at the end of a rope 30 centimeters long makes 10 complete oscillations in 2 seconds. So we have to find the angular speed in radian per second, the linear speed, and then the distance covered in 5 seconds. So let's solve. So let's start with the angular speed. Now, remember we are solving in radian per second. We should know that 1 revolution is 360 degrees, which is basically 2 pi. Okay, so that is 10 revolutions will then be 2 pi times 10, which is 20 pi rad. Okay, that's in radian. So now to find this, we would have theta over t. So since we are working in radians, we're going to use this. So 20 pi rad in 2 seconds. Now this would give us 10 pi rad per second. Okay, you can then go on to apply pi. If pi is 3.142 or 3.14, we can then say w equals 31.4 radian per second. That will be the solution for the angular speed. Now to get the linear speed v is wr, okay, and the radius is given as 30 centimeters, which is basically 0.3 meters. So all we have to do here is say v equals this, which is 31.4 rad per second, multiplied by the radius, which is 0.3, which is in meters, right? So v here therefore becomes, now let's multiply this, 31.4 multiplied by 0.3. So what do we have here? 3 times 4, that will give us 12. 2 carry 1. 3 times 1 is 3 plus 1, that's 4. Right? 3 times 3, that's 9. And then this would give you 0, 0, 0. This is 2, 4, 9, 0. And this would give us 0.942 meter per second, and that's the velocity, linear velocity. Now, distance covered in 5 seconds. Distance is supposed to be velocity multiplied by time. So velocity is 0.942 meters per second multiplied by time, which is 5 seconds. Now, when we multiply this, what do we get? Let's see. 0.942 multiplied by 5. This is 10, 0 carry 1. 5 times 4 is 20 plus 1, that's 21. 5 times 9 is 45 plus 2, that's 47. 5 times 0 is 0 plus this, that's 4. So 4.710. So that's basically 4.71. And this is meters. So, and this is the solution to this problem. Please don't forget, if you're yet to be subscribed to the channel, kindly take a moment of your time, hit the subscribe button, and also hit the notification bell icon so that you get alerted every time I put out a new content. And please don't forget to share the video so that we can reach many more others that need content like this. And if you have any question at all, drop it in the comment section and we'll attend to all of your comments. This question here says a particle of mass 10 to the power of negative 2 kilogram is fixed to the tip of a fan blade which rotates with angular speed of 100 rad per second. Now, if the radius of the blade is 0.2 meters, we have to find the centripetal force. Now, let's see how we solve questions like this. Solution. Now, what do we have here? We are given that mass is 10 to the power of negative 2 kilograms. Okay? We are given the angular speed as 100 rad per second, and we are given radius as 0.2 meters. Now, we are asked to find centripetal force, and centripetal force is mv squared over r. But v is wr, isn't it? So let's impute that here. We can then say Fc equals m wr in bracket squared over r. Now this will give you mw squared r squared over r, which is basically mw squared r. So you see how the equations that we did for linear velocity relating with angular velocity can be related with the centripetal force that we've learned how to solve. So now let's apply this formula and see what we get as our answer. So centripetal force therefore becomes the mass, which is 10 to the power of negative 2, multiplied by, now this would be 100 squared. Then we multiply this by radius 0.2. Now this means we are having, by the time you apply your calculator to this, you should come up with 20, and it is measured in newtons. So the solution to this question is 20 newtons. Now in this question, we have that a mass of 0.5 kilogram is whirled in a vertical circle of radius 2 meters at a steady rate of 2 revs per second, and we have to calculate the centripetal force. Now, I can solve this the same way we've been doing, but I can also show you something new to this. But let me show you both so that we all learn at the same rate. Now, to solve this, the method we have been applying before now, we have to first get W, okay, which is angular speed. To get the angular speed here, we need theta. Remember, theta over time. So how many revolutions is completed here? 2 revolutions. And 2 revolutions means we have 2 times 360. Okay, over 1 second. So what this means is that we have 720 over 1 second. Now we can convert this to rad per second. Now recall that pi equals 180 degrees. Okay, so what we have here is basically 4 pi, right? So 4 pi is 720 degrees. So we can then apply this and say W equals 4 pi rad per second, which is 4 times 3.142 rad per second, and then we can use this to get the value of 12.56 rad per second. Now, applying centripetal force Fc equals mw squared r, that is, we are having 0.5 multiplied by 12.56 squared, and then this multiplied by the radius is given as 2 meters. By the time you apply your calculator here, you should get 157.75 newtons as the centripetal force. Now, here's another thing you can do. Instead of going through all this process to get the angular speed, you can also apply angular speed equals 2 pi f, where f is frequency. Now, from here, W is therefore 2 pi multiplied by the frequency is what we have here, which is 2 rev per seconds. So from here, you see, you easily get this as 4 pi, which is exactly what we got here. And converting it to rad per second, you just say 4 pi is 12.56 rad per second. And then you just impute it into this formula, and then Fc is still 157.75 Newton. So either of this way can end up getting the centripetal force. But I just believe this method is way easier for you. So please note, angular speed can also be 2 pi f, where f is the frequency. And this applies every time you have a question where you are given the revolution per second. So this is the solution to this question. Now let's solve this question where we have that a particle moves in a circular orbit of radius 0.02 meters. Now if the speed of the particle is 0.88 meters per second, we have to calculate its frequency in circles per second. So here's the solution. Now we are given V as 0.88. Okay, we are given R as 0.02, and we need to find F. Now, how can we relate all of this together? We know that V is supposed to be WR, right? Which implies that V equals, since W is 2 pi F, we say 2 pi FR. So let's find F here. Frequency therefore becomes V over 2 pi R. Now what is V? 0.88 divided by 2 times, let's use pi as 22 over 7, then multiply by R. R is 0.02. So when we solve here, what do we get? Easily we can see that this is 0.88 over, now 2 times 22 is 44 times 0.02, all divided, this one divided by 7, which means 7 goes up here. Now what we have here now is 7 times 0.88 over, now 44 times 0.02 will also give you 0.88. So this cancels out. So the frequency is therefore 7 rev per second, or basically 7 hertz. So this is the solution to this question. Now, while you're studying, please check out many other questions on circular motion and try them out using the hints that we have given in these videos. And if you have any challenge with any of those questions, we would like you to put it in the comment section, and we'll be glad to assist you in every way that we can. So please keep your comments coming, and please don't forget to subscribe. If you haven't done that already, please click the subscribe button and the notification bell icon so that you get alerted every time we put out a new video. And please help us to reach many other students that need videos like this by sharing the video. Just click the share button and help us share this good news to as many people that need videos like this. Thank you so much for following the video so far. We'll be moving on to the next topic. I'll be seeing you in that video. Bye.